I notice a lot of students having problems with question 7 and 8 on the heat practice problems. So let's go over that today. Okay, question 7 says, how much energy is needed to turn 670 grams of water from 70 to 0 degrees Celsius and then freeze it at 0 degrees Celsius? So I like to draw out my heating graph for water. We know it freezes here at 0 degrees and boils at 100. Now I am starting off at 70 degrees, so it's around between these 2 points. And I'm going to go from 70 to 0 degrees. So that's a first step. So that's our change in temperature. And then we're going to freeze it at 0 degrees. That's just telling us it's at water. So we're going to freeze it here. So that's 2 steps. The first step, we're going to have a change in temperature. So we're going to use our MCAT equation to solve for Q. And our second step, because we're freezing it, this is where fusion happens, we're going to use the heat of fusion equation. So let's write down the variables that we do know. Let's write down the variables we do know. We know our mass is 670 grams. We know our change in temperature. Okay. Final minus initial, so we're starting at 70 and we're going to 0, so it's going to be 0 minus 70, so we're going to end up with negative 70 degrees. And we know our specific heat for water is 1, and that is calories per gram degree Celsius. And we know our heat of fusion for water is 80 degrees, 80 calories per gram. Okay, so let's do our step 1. So our step 1 equation, we have mass times specific heat times the change in temperature. That gives us negative 46,900 calories. Our step 2, we're going to use the heat of fusion. Now, it's important to know which direction are we going on our heating graph. We're going down the heating graph. So that means our heat of fusion, we are going to make a negative because we're cooling it down. So we're going to take our mass and multiply it by a negative 80. Which gives us negative 53,600 calories. Okay, so that's how much it takes to cool it down from 70 to 0 degrees. And then this is how much it takes to freeze it. So our total heat energy is going to be negative 53,600 plus negative 46,900. Which gives us negative 100,500 calories. Okay, now going on to question 8. How much energy is needed to turn 48 grams of ice at negative 25 degrees to 100 degrees Celsius? So again, let us write out our graph up here. And we're starting at negative 25. and we're going up to 110. So to get from here to here, we first need to warm up to 0 degrees. Then we need to melt it. Then we need to warm it up again. And then we need to boil it. And then warm it up again. So how many steps is that? 1, 2, 3, 4, 5. 5 steps. So let's go through our 5 steps. First step is to warm it up from -25 to 0 degrees. So that is a change in temperature, so we're going to use our MCAT equation. Okay, second step, we need to melt it. Melting happens using our heat of fusion equation. Step 3, we need to go from 0 to 100 degrees. Now that's a change in temperature, so we're going to use our MCAT equation. Step 4, we're going to boil it. So that is our heat of vaporization equation. And last but not least, we need to warm it up from 100 degrees to 110, which is a change in temperature, so we're going to use an MCAT equation again. We cannot just subtract 110 from -25. That you cannot do. You have to go up in stages. My challenge to you is now try to solve this equation on your own.